In this video, we will learn about equations of motion. So for a uniformly accelerated motion of an object along a straight line, we can easily correlate it with velocity, acceleration and the distance covered by it in a given time interval by a set of three equations. These equations are known as equations of motion. These are as follows. First is the velocity-time relation. So let a linear object start moving with an initial velocity u during its motion under a uniform acceleration a, and final velocity of the object becomes v after a time interval of t. So as per the velocity time relation, we have v equals u plus a t. Okay. Now, second would be the position time relation. So let an object start moving with initial velocity u, has a uniform acceleration a, total distance traveled would be s, or the magnitude of displacement covered by the object in time t. So the relation we have would be s equals ut plus half at square. Third is the position velocity relation. Let an object start moving along a straight line with a constant acceleration a such that its velocity u to v changes while covering a distance s. So the relation would be v square minus u square equals to as. The above mentioned equation of the motion can be obtained analytically as well as by graphical method. Okay. Now, derivation of velocity time relation by graphical method. So, the velocity time graph for a uniformly accelerated motion along a straight line is shown in this particular figure. Now, the graph is a straight line where point A corresponds to the initial velocity u at time equals 0, and point B corresponds to the final velocity v at time interval t. Now, the velocity changes at a uniform rate a. Okay. Now we draw a perpendicular, that is BC, on time axis and BD on velocity axis respectively. Now we draw a perpendicular AG from point A on the line BC. Okay. From this graph, it is clear that BC would be equal to V. This is V, that is final velocity. AO is the initial velocity U, and GC would be U as well. Okay. So we can say that BC, that is this big line, would be equal to BG, that is this line, and GC, that is this line. And we know that, so BC would be equal to BG plus GC. Okay. And we know that velocity BC is capital V, BG is what we have to find, and GC would be equal to U, right? So we can simply say that BG would be equal to V minus U. Now, as per the graph, acceleration would be equal to change in velocity upon time taken, where it is equal to Bg divided by Ag, or dA divided by OC, okay, which is equal to V minus U upon T. Or I can say V minus U equals AT, or I can say V equals U plus AT. So this is how you can derive this equation. The second method is the analytical method. So by the definition of acceleration, we can say that acceleration is change in velocity upon time taken, right? So it would be final velocity minus initial velocity upon time taken would be equal to acceleration. So if I send this there, so velocity change in velocity can be equal to at, and v equals u plus at. So this is the second method. I hope this topic is clear to you. Thank you.